Alrighty guys, in this video we're going to be setting up our player and creating our first program so that when we start the game we can assign our player a starting position. Now what we're going to be doing is we're going to be covering a few coding concepts as we go along. So let's go ahead and start with setting up our player. Go ahead and open up your player turn left folder under your sprites. Select the first frame, which is player turn left trip or quad zeros, and drag this into the hierarchy view or the scene view, whichever you'd like. Go ahead and rename this to player, and this will be our player for the remainder of the game. Now it's a little large on my screen, so I'm going to go ahead and shrink it down to about 35%. So go ahead and change the scale value to 0.35 on the X, Y, and Z. Alright, I'm perfectly fine with this size, and I'm going to go ahead and just move them over here. So what I want to do is essentially when we start the game, I want its position to snap to 0, 0. And you can see that we're affecting the position, which is part of the transform component. So what we're going to do now is we're going to go ahead and create our first C# script. Before we do that, let's create a folder to store all of the scripts for our game. So we're going to call this scripts. We're going to right click and create a new C# script. Let's go ahead and name this player and go ahead and double click it. Now, if you installed Visual Studio 2017, it should open in Visual Studio 2017. If you're on a Mac, it should open in MonoDevelop. Now, if you are on a Windows machine and you did install Visual 2017, however, it opened in MonoDevelop, it just means that it didn't detect your proper settings. So head on over to Edit, Preferences, External Tools, and External Script Editor, and change it to Visual Studio 2017 or MonoDevelop. If you don't see it selected here, you can browse and find the exe file to open Visual Studio. So now that we have our script open, let's go ahead and take a look at what this is. What we're looking at here is a class, and you can think of a class as a blueprint for your program, or in terms of Unity, you can think of this as a behavior. So we can add scripts to our game objects. So for instance, we created this player class, head back over to Unity and drag this script onto our player. And what you'll see here is that our player now has a player component. All right, that's what's unique about Unity. Everything is a component. It's a component-based design. So now our player has a transform component, which holds the position, rotation, and scale, a sprite renderer, as well as a player component, which is the script we created here. And essentially, it's going to define the behaviors of our player. It's going to handle our movement, it's going to handle our shooting, and it's going to handle picking up power-ups later in the game. So the first thing we want to do is let's go ahead and take a look at the syntax for a class. What we have here is public class player. This player is the name of the file. It must match. Here, this colon stands for inherit, and what it's doing is it's inheriting from MonoBehavior. This right here is the reason you're allowed to just drag this script onto a game object. MonoBehavior is what all components are made up of. So technically what we have here is void start and void update. These methods are provided to us from Unity because they're part of the MonoBehavior runtime. And then up here you have namespaces, which we're not going to get too involved with, but just know that namespaces are libraries that have information about writing code. So for instance, the reason why we are using Unity Engine is so that we can inherit from MonoBehavior, which allows us to use these default methods. These methods are given to us by Unity and have very specific functions. As you can see here, there's comments above them. Use this for initialization. So void start is called as soon as you start the game. It's called one time. Update is called once per frame after start. And typically on your computer, you're going to get about 60 frames per second. Okay? So what we want to do first is let's go ahead and just print a message to the console on start. So as soon as you hit the play button, let's go ahead and print out hello. To do that, we're going to go ahead and type debug.log. Now, as you type debug.log, you should get a tooltip with IntelliSense from Visual Studio or MonoDevelop. And what you're going to notice, and it's so important to read your tooltip, as I type debug.log, you're going to see here that the syntax is void debug.log, open parenthesis, a message, close parenthesis. So I open a parenthesis, And you can see here the tooltip is telling me that logs message to the Unity console. I can go ahead and add some quotes in here and say hello. Now what's also important is that every line of code must end with a semicolon. Go ahead and save this script, head back to Unity, make sure our player has the player script, and go ahead and run the game. You'll notice down here on the left it says hello. And here, if you go to the console view, it says hello. Now let's go ahead and check out the update method. Go ahead and write another log that says your name, Jonathan. And don't forget, always add a semicolon. Go ahead and stop Unity and rerun it. And you'll see here that right now, it's constantly printing out Jonathan because it's happening every frame, typically 60 frames per second. And you can see here it's counting very rapidly. And if I hit collapse here, you can see the project or the script went from top to bottom with starting with the start method and then moving on to the update method. So that's how these methods work, and they're by default enabled through Unity's mono behavior. Now let's go ahead for an example. Say I wanted to remove this mono behavior here. Right now what we have here is just a normal C# class. And if we go ahead and save this and head back into Unity, you'll notice here that I can no longer just drag this back out. It says nothing selected. Let's remove the component and try adding the player script onto the player. It says can't add script behavior player. The script needs to derive from mono behavior. So that's where this Unity Engine library comes in. It allows me to type inherit mono behavior. Now because it's a mono behavior, I can head back over to our player and I can drag my player script directly on it and you'll see it works just fine. Now how would I know if I was working in a blank script, how would I know that I can use void start as well as void update? And you'll notice that the IntelliSense on Visual Studio is sort of auto-completing it for me. How would I know that I can use these? Well, these are part of the scripting reference for the mono behavior. So let's go ahead and check that out and see what else we can do. Head back to Unity, click on your player, and you'll see this little blue icon book. This is the scripting reference. Go ahead and click on that. This will open the Unity manual. And what we're interested in is the scripting API. Specifically, I want to look at the mono behavior runtime class. So let's drop down this Unity engine and see if we can find it. We are looking for mono behavior. Let's see here. I do not see mono behavior showing up here. Let's go ahead and let's just go to Google. And let's go ahead and do a mono behavior search. So we're going to say Unity scripting API mono behavior. Whoops. Okay, here we go. Script API mono behavior. Perfect. Okay, this is what I was looking for. So check this out. Here we are in the Unity API, and it says description. Mono behavior is the base class from which every Unity script derives from. When you use C#, you must explicitly derive from mono behavior. And that's the ability that allows us to drag and drop those components. So check this out. Here we have start and update, and then here's some other ones that can also be used for initialization. For instance, we have awake, which is used for the loading of the scene. And as soon as the scene is loaded, then start is called, then update. And then we have a physics update as followed by a late update. And then your graphics are displayed, and then followed by, this gets called automatically when the object gets disabled, followed by gets called when it's enabled. Now, as you can see here, we have public functions as well as messages. And these messages are very important because this is technically what we're using. And you can see here, look at all the amazing things Unity allows us to do. For instance, we can check for collisions using the mono behavior class, which we'll be doing later on. We can destroy things. We can check for events. We can check for when our mouse enters a collider. There's all sorts of things that we can do because of mono behaviors. Specifically, what I want to find is our void start and our update methods, which you can see here. And it says start is called on the frame when a script is enabled just before any of the update methods is called. And for update, update is called every frame. If you click on it, you'll get a code snippet of how to implement it. You can see here, they have a public class, example class, which inherits mono behavior, very similar to what we have. And then they have void start with a parenthesis, like open close parentheses followed by curly braces. So that's where we can find information about what mono behavior is and how we know that works. Now in programming, syntax is everything. So for instance, if I rename this to lowercase s for start, this is now a custom method that is not part of the Unity runtime. Unity won't recognize the syntax and will not call this method. So it's very important that your syntax is identical to what's in the scripting API. So that's our brief overview of this class. In the next video, we're going to go ahead and look at reassigning a position and how to get the current position.